This is a presentation on the actions and strategies of the Adaptive Environmental Management Plan being developed by Candace Kovacs for the Environmental Management Course project through American Public University. This adaptive management plan is on sustainable agriculture using center pivot irrigation and agricultural drones. The agenda items are the topic, the vision statement, the DJI Gross MG-1, which is a specific drone chosen for this management plan. Then we will move into the management alternatives, success criteria for the plan, a brief summary, which will be followed by the reference slides. The topic for this adaptive management plan is the use of agricultural drones for applying nitrogen fertilizer on crops. Maintaining proper nitrogen levels in fields using center pivot irrigation systems and the addition of agricultural drones will be an innovative way to save money. It will also allow for growing a higher yield crop for sustaining our agriculture, and this method of application is on the rise. The vision is to deliver an innovative way for using agricultural drone technology in order to produce higher crop yields. Our long-term commitment to this mission will make us a market leader and help improve the quality and quantity of crops for the world's growing population at a lower cost. The DJI Gross MD-1 is a specific fixed-wing drone made for agriculture and is top of its class, but it also has a foldable alternative for easier transportation. It was created specifically for agricultural business use as it provides a variable rate application for liquid pesticides, herbicides, and most importantly, fertilizers like nitrogen. The pros for this drone are the variable rate application, impressive payload, efficient mapping, its overall speed and power, the accurate spraying capacity, intelligent memory, and its longevity. These drones bring efficiency and manageability to any farm. The propulsion system is powerful enough to carry large payloads of liquids to crops in the field. With that ability, it is one of the best heavy lifting drones on the market. It combines power and speed for mapping and can cover 4,000 and 6,000 square meter area in approximately 10 minutes, which is 40 to 60 times faster than that current manual spraying operations such as a center pivot irrigation system. It has a smart spraying system, and combined with the speed it provides and the ability to automatically adjust the spray due to the speed it travels allows it to create an evenly applied spray. It also has interchangeable spray nozzles for the different liquids that it can carry. The propellers create a downward airflow that allows for an increase in the reach the drone generates. The DJI Gross MD-1 has a light airframe made of high-strength carbon fiber with a sealed body and integrated centrifugal cooling system to prepare it for the dust and corrosion of the farm. While in flight, the air around it enters the body of the aircraft from the front inlet, where there is a triple filter system that keeps the dust and debris from getting inside. With the ability to cool and filter, it creates a higher lifespan expectancy for each of the motors. Management alternatives to the DJI Gross MD-1 would be other agricultural UAVs such as DJI Matrix 100, Precision Hawk Lancaster 5, Sendafly EB-SQ, and the Ag Eagle RX-48. When considering the purchase of an agricultural drone, you need to consider many factors for your farm. Flight time and durability are the top two things your drone will need. The payload that it will be carrying will reduce the flight time. Drones on a farm will be in a dirty environment and a heavy workload, so consider the durability and weight carefully. There are many uses for agricultural drones, such as mapping, weed spotting, managing crop health, and even livestock. Today we are discussing drones for the use of fertilizing crops. Agricultural drones are equipped with many forms of technology from infrared cameras to GPS systems. Drones are programmable, and the use of a proper data processing software is just as important as a drone itself. These allow for the ability to make a better management decision for proper fertilization on farm fields. Determining which drone is going to work best for you need to know what they can provide and choose the one with the most for your farm needs. Some of the many things that you need to consider are durability, customization, flight time, payload flexibility, ease of flying, sense detecting for obstacles, landing, takeoff, rate application variability, mapping, speed and power, accuracy, memory, and longevity. Nutrient deficiencies such as nitrogen can be interpreted precisely with spectral reflectance using the high-resolution UAV images. The UAV can have thermal or multispectral cameras equipped to gather information all at once with precision. Nitrogen is a very significant element needed for proper crop growth. Nitrogen affects the content of the leaf area index, chlorophyll, and protein. Remote monitoring of nitrogen can provide a theoretical foundation for crop production. This adaptive management plan has chosen the DJI Gross MG-1 based on the main features, but it can be ineffective in certain areas, and if so, a different drone may be a more suitable option. There are many different UAV programs that can be used. Climate Field View, Chidu, Pix 4D, Agasoft, Drone Deploy, Precision Hawk Data Mapper, and Centera Field Agent, to name a few. The UAV program is just as important as the UAV itself, but they tend to be used for mapping mainly, and we can discuss this in a later discussion. The FAA must approve a drone to be equipped with large reservoirs that would carry the nitrogen fertilizers. Using a drone for using a drone for application is safer and more cost effective. The operation of the drone can be all autonomously and programmed to a specific schedule or route that the farmer sets up. The farmer can become a certified drone pilot or pay for a professional agricultural drone pilot to come to their farm. The key concerns for using agricultural drones is recognition of the drone's ability and measuring its effectiveness. In an adaptive management project, we must assess and compare the cost of using a drone versus current methods. We need to minimize uncertainty. Things that need to be recognized is their ability to apply the nitrogen fertilizer to the crops. You need to ensure that the proper amount is being applied into the proper locations. Nitrogen deficiencies will significantly reduce crop yield. The DJI Gross MG-1 has a precision variable rate application of fertilizers. This brings efficiency and manageability to any farm. This drone can carry a heavy payload up to 10 kilograms of liquid fertilizer and many other liquids. The customization of the spray nozzles are important in order to provide a complete application of all liquids a crop may need, not just limited to the nitrogen that we are discussing today. Measuring the effectiveness of the drone would be through its intelligent memory, such as the ability for it to know when to adjust the spray. The spraying system in this drone is intelligent in that it can automatically adjust the spray according to the speed it is flying in order to get an even application and not over pollute. The ability for a drone to be customizable is important. The DJI Gross MG-1 can choose the specific spray nozzles in accordance to the properties of liquid it is spraying. It comes with interchangeable nozzles that are resistant to wear and degradation and can be used for thousands of hours. This longevity is important. The drone can also detect its battery life and depleted payload and quickly land in order to get a reload. In summary, to include uncertainty in the decision-making process, first we must acknowledge what we know. Each drone and program can be used and altered to certain specifications, but each may have cons to the design or use. Being able to find the right drone and program to create the best efficient application may be different per farm or crop. We also must discuss that we do not know which drone works best with which program, the user, the farm, and the crop that each of these are best suited for. To make sure we get consensus from all stakeholders, we need the right drone, program being used on the correct farm and crop. We must continue to apply decision making, follow-up monitoring, continual assessments, continue to learn, and gain feedback. These are all the references used for this PowerPoint presentation. That is the end. Thank you so much for watching.